Hello, ladies and gentlemen. Hopefully the sound started. We are going to do sections 2.3 to 2.4 today, and we're going to continue talking about derivatives. We're going to talk about the product, quotient, and chain rules, and then we're going to review the 6 trig function derivatives. So I'm going to do just kind of write the rule. That was really bad grammar. So here's our product rule, and then I'll do an example or two and we'll use it. So the product rule is if I have two functions multiplied together and I want to take the derivative of the product, it's the first function times the derivative of the second function plus the second function times the derivative of the first function. So that was pretty easy. The quotient rule has its own little sing-songy kind of thing. So if I want to take the derivative of f of x divided by g of x, if you'll remember, it is low d high minus high d low over low squared. Ta-da! Next one is the chain rule. And this is the one I feel like you guys had the most difficulty with last year, because you have to keep going until you run out of things to take the derivative of. So, for example, if I want to take the derivative of this composition, it's going to be the derivative of the outside, the inside stays, times the derivative of the inside. And I have heard it said, what starts inside stays inside, and then you ultimately end up taking the derivative of the inside. So remember, if you are using the chain rule, you do have to keep going until you run out of things to take the derivative of. So for example, if I ended up with a constant, I can't take the derivative of the constant because then it's 0, and then that would negate the whole thing. It would make everything 0, so then it's just no fun. All right, let's do an example. We'll do a different color because we can, of our product rule. So let's say my function is 6x plus 5, and I'm going to do x cubed minus 2. So if I take my derivative, it is the first thing times the derivative of the second, which is 3x squared, plus the second thing times the derivative of the first. I know that's really technical math language. And then I need to clean all of this up. So remember, we always want to clean it up and make it look nice. So my derivative is going to be 18x cubed plus 15x squared plus 6x cubed minus 12. Combine like terms, and I get 24x cubed plus 15x squared minus 12. I identify my answer, and then I'm done. So that was actually kind of easy. Alrighty, now let's do an example of the quotient rule. Here's my example little box. And we're going to do an example of the quotient rule. The function that I'm going to be given is, oops, I turned the page too soon, x cubed plus 5x plus 3 over x squared minus 1. So if it's helpful, say the little sing-songy kind of thing as you do your derivative. So for my derivative, it's low times the derivative of the high, 3x squared plus 5, minus high, x cubed plus 5x plus 3, times the derivative of the low, all over the low squared. All right, and I would not choose to leave it this way. I would clean it up, especially if you had to take a second derivative, because this would just be too messy. So if I clean up my derivative and I do this math, I get 3x to the fourth plus 5x squared minus 3x squared minus 5. And then I'm going to have a minus 2x to the fourth minus 10x squared minus 6x all over x squared minus 1 quantity squared. And again, I would clean it up just a little bit to combine my like terms. 3 minus 2 is going to be x to the fourth. And then I got rid of those two guys. Now I have 5 minus 3 is 2. Minus 10 is a negative 12x squared. Minus 6x minus 5. And I am not going to expand the bottom. So at this point, I would just leave it like that. All right, our next example is going to be of the chain rule. I love the chain rule. I think it's pretty cool because it challenges my brain a little bit. So I'm going to say our function, my computer keeps being weird, sorry, my function is going to be sine cubed of 4t. But remember, if we're thinking about doing the chain rule, I could write this as the sine of 4t quantity cubed, because I think that makes the chain rule a little bit easier. So if I take my, oops, I got t's and x's going on here, my bad, we'll call that guy t. So if I take my derivative of t, I'm going to do the outside first, so I have 3 times the inside, so what starts inside stays inside. This goes to the 2. Now I'm going to take the derivative of the inside, which is going to be the cosine of 4t, and then I'm going to take the derivative of the inside again, which is 4. And I've run out of things to take the derivative of because I don't want to take the derivative of 4, because that would just screw the whole thing up. So my chain rule is going to give me 12 times sine squared 4t times the cosine of 4t. And then I would call it good and leave it there. Because then I could substitute values in and I could calculate my slope. So you do just have to remember that you have to keep going until you run out of things to take a derivative of. All right, I have one more example of the chain rule because I feel like this was one of our most difficult derivatives last year. And this one's actually a little bit simpler. But let's say I have 2 times 6 minus x squared to the fifth. So if I start taking my derivative, the 2 stays, the 5 comes down, what starts inside stays inside, that goes to the fourth, and then I'm going to take the derivative of the inside, which is a negative 2x, and then I'm going to take the derivative of the inside, which is a negative 2. Alrighty? I think I'm good. So when I do this math, I get a negative 20x times 6 minus x squared to the fourth. And now that I look at this, I think I went one step too far, so I think I should not have done that. So then if I just take off a negative 2, I'm going to end up with, here's my 10 times 2. I did bad math anyway, my bad, right? So silly me. I got the right answer, but I did too many derivatives because once I get down to the negative 2x, I've taken the derivative of the inside, so I don't have to take the derivative again. Alrighty, so I think we're done. The next topic that we just want to go back and remember, because remember you're responsible for remembering a lot of formulas for your calc test. So we're going to talk about the derivatives of our trig functions, and remember that you might need to memorize these guys because you just want to make sure that you know the basics. So the derivative of the sine of x is the cosine of x. The derivative of the cosine of x is equal to a negative sine of x. And then the derivative of the tangent of x is equal to secant squared x. And then we're going to explore our reciprocal relationships. So if I take the derivative of secant of x, then I get secant x tangent x. If I take the derivative of the cosecant of x, I get a negative cosecant cotangent of x. And there's kind of a cool pattern going on there, so you can use that to help you remember what they are. And then my derivative of the cotangent of x is going to be a negative cosecant squared x. And that's it for today, you guys. So I think you should be good to go. I'm going to try to stop this at the correct time. So I hope everything went well, and I will see you tomorrow.